first order differential equations. So this is really connected to implicit differentiation. When you had something where it wasn't easy to get the y by itself, we used implicit differentiation. Implicit differentiation said just do d dx of both sides. And whenever you had a y, well, the derivative d dx of y is just dy dx. So we deal with everything like normal derivatives. So derivative of x squared is 2x. The derivative of y squared would be 2y, but because we had a y, we have to do the chain rule and multiply and get a dy dx. And the derivative of 16 is 0, so we could rearrange this, and we would get dy dx equals negative 2x over 2y. In other words, dy dx is equal to negative x over y. Now the problem is if you had that as your differential equation, how do you undo implicit differentiation? We've never done that. We can undo regular derivatives, but if this is your derivative, how do you undo that when there's an x and a y? Here's the idea. If we started with this, and this is very similar to the x over y, but this time it's x squared over y. What we're going to do is separate the x's and the y. In other words, we're going to move the y's to one side of our equation and get y dy, and our x's to the other side of the equation, getting x squared dx. And then integrate both sides. Well, the one side you're integrating with respect to y. The other side you're integrating with respect to x. And both of those are easy integrals to do. Add 1 to the exponent and divide. And your C1 on the one side and your C2 on the other side, you could just put that together and say there's some constant C once they get put together. In fact, this is the one place on the exam where I find they're quite lenient. If you wrote plus C here and wrote plus C here and then wrote them together as plus C again, they'd be like, technically you know those should all be different because they could all be different numbers. And if I do C plus C and I get C, it's sort of like something not quite right. But they're a little bit lenient on that. But I like to be meticulous. So my first one I do C1, my second one C2. When I put them together, I could put C3. But as long as you're introducing different variables along the way, you're fine. So this becomes our implicit equation for this one. Right? And if I multiply everything by 2, I could get the y squared by itself. But when I multiply by 2, shouldn't I get a 2c? Should I add c4 now? Sounds like that's explosive or something. So again, they're a little bit lenient if you just have, you're like, it's another constant there. This would be the explicit equation. Explicit is when you can get the y all by itself. I'd have to square root both sides. So the idea is this, and we can even go back to our very first one, is if you have a differential equation that involves x's and y's, you want to separate it to get the y's on one side and the x's on the other. And then when you integrate both sides, one side you're integrating in terms of y, the other side you're integrating in terms of x. Let's look back at our very first equation just to have this, like we did our implicit differentiation, and we got dy dx equals negative x over y. So if you had started with this and wanted and didn't know, they just gave you, hey, dy dx is negative x over y. What equation was this? Well, I could get my y's, I can multiply both sides by y to move the y to the top of the other side. I can multiply both sides by dx to get my dx on that side. And now I separated my y's on one side, my x's on the other. When I integrate both of these, add 1 to the exponent and divide, plus c1. Add 1 to the exponent and divide, plus c2. I could move everything over to one side. So I have y squared over 2 plus x squared over 2 equals some constant c. And I could multiply everything by 2, saying I should get x squared plus y squared equals something. Is that what we started with? Yes, we started with x squared plus y squared equals 16. Working backwards, we said, yes, that's the form it should be. C could have been anything. It could have been 16, it could have been 25. Anybody know what this is? As a graph. It's a perfect circle. When you have x squared plus y squared equals, it's actually r squared. If we graph this, it'd be a perfect circle with a radius of 4. Is it a function? No, it's a relation. Because it doesn't pass the vertical line test. But if you pick this point at 2 and drew its tangent line, that point at 2 would actually have, this would be 2 comma, what would I have to put in there? 2 comma root 12, and because it's the neg, is that math right? Looks like it. That would be the point 2 comma root 12. My implicit differentiation told me dy dx is negative x over y. The slope of this red line that I just drew on that circle would be negative 2 over negative root 12, which ends up being positive. But I just found the slope of that line on the circle at that point. Using my implicit differentiation, sort of connecting all the ideas that we've had up till now together. Now we can have crazy shapes, still find slopes of tangents. But what's crazy here is there's also two comma root 12 up there. And its slope is negative 2 over root 12. Negative because it's going down, obviously, from the picture, but also from the equations it shows up. So this is separable first order differential equations. The idea is when you have a differential equation with an x and a y, you want to get your x's on one side, your y's on the other. In particular, when you get your x's on one side and your y's on the other, you need to make sure the dx is on the top on one side, the dy is on the top of the other. So in this case, I need to move this dx up to the top over here, which means I'm going to need to move this root y over to the left side. If I do that, I'm going to get a square root of y on the bottom, which is the same as a y to the negative a half. Can I integrate both of these? I think so. I'm okay if you skip the step I'm not going to show you. So the step that I didn't show you had the plus C1 on one side, the plus C2 on the other side. Those are gonna be put together as a plus C eventually. Does that make sense? So if I'm okay with you skipping that step, are you okay with me not showing it to you? Because then some of you are, I don't know what type it is, type A, type A plus, I'm not sure. If I uncover that box, you will physically not be able to not write it down, right? You are out there. Those are the type of people. There's some people that don't have to write things down. We know who you are. And then from here, if you wanted to, you could get y by itself. Technically, this is a solution as well. But getting the y by itself is nice for solving things later on. All right, there's 4 of them on the next page. Try those 4. I'll show you all the answers tomorrow. Not tomorrow. I've decided to give you tomorrow off.